For part two of our study on classifying polar equations, we're going to write some equations. Now, we're going to end up using the same chart that you guys made up yesterday, but this time I'm going to maybe give you some information or a graph, and you're going to have to go backwards. You're going to have to write the equation. Now, it's a pretty easy lesson. If we were doing this in class, I would be asking you guys to come up with the answers. So make sure that you're doing that. Make sure that you're not just waiting for me to get the answer, but you come up with the equation. For example, of a polar cosine circle that has a diameter of 6. So what do you think? What would be the equation if it was going to have a diameter of 6? Pretty easy, right? This is just going to be of the form r equals a cosine of theta. So we're going to have r equals 6 cosine of theta. And that would be a polar cosine circle that has a diameter of 6. How about just a polar circle that has a diameter of 6? Oh, wait a minute. Is this different than a sine or cosine circle? Well, indeed it is. Remember, this kind of circle is the one that is just of the form r equals a. Now, when we're of the form r equals a, remember that a is the radius. A is the radius. So, if I want to have a circle that's a diameter of 6, then I would have to say that r equals 3. That's correct, r equals 3. Now, you might want to add this to your chart. We did do it the first day of this chapter, but sometimes students like to, at this point, add to their 3-column chart. That is what I already said here, that we have a circle. It's of the form r equals a, and you could even say that a is the radius. And if you would like, you could add our example, r equals 3. And do you realize how this graph would be different? Do you realize that it would be a circle that's centered at the pole? So we have a little bit of a variation on our circles. Ready to move on? What did we see over here on this one? A polar sine Limacon. This time it's going to have a size of 9, but contain a loop of size 3. What you're really wondering is what this is right here, right? Well, this is the only picture I could find on the internet of a lima bean. And I think it's wearing earmuffs. It must be cold. Now remember, if it's going to be a Limacon, do you remember what that equation looks like? It's going to be a Limacon. Well, that's right. Go back to your notes and use the a plus or minus b sine of theta. See if you can fill the numbers in correctly. We want to have an overall size of 9, but we want to have a loop of 3. Now, this is like a little puzzle. What we're really looking for here are two numbers that add to be 9, but they actually subtract to be 3. And so you would have to use the numbers 3 and 6. Okay, because remember, when you add those numbers together, kind of like the absolute value of 3 and 6, we end up with 9. It's going to be not really the diameter of the shape, but it's going to be the size of it. But when you subtract these numbers, since a is less than b, you'll get the size of the loop. And that'll end up also being 3. This isn't a bad problem for you to graph on your calculator. If we were doing this in class, I'd pause for a couple of these, which we're going to do now. If you type this in your calculator with the plus sign, so we can type in 3 plus 6 sine of theta. We'll go to Zoom Standard. And we end up with a Limacon, but we get that loop in the middle, kind of like when you did that one on your homework, okay, because we get those negative numbers as we rotate around, and that's what draws the loop. What about the minus sign? We haven't talked too much about that. Some of this is just for you to explore. You can see that we actually end up with, we would say, like a reflection of the shape. And this time your Limacon is facing down. All right, so there's your Limacon. How about a rose? And by the way, have you given somebody a polar rose yet? Make sure that you try that. I want to know how that goes for you. Give someone that you really care about mathematically, give them a polar rose. Now, if you could give them a polar rose that has 6 petals that are 8 units long, well, you might really be in love with them. Why would you really be in love with them? 6 petals, 8 units long. How's that going for you? Remember the form of a rose? It's the n theta. The n theta is kind of what gives this one away. Now, if they're 8 units long, we want to have an 8 out here. How about if we want 6 petals? Well, could we put a 6 there in for n? Could we? That's right, we can't, because since 6 is even, that's going to actually give us 12 petals. Uh-oh. Since 6 is even, we're going to double that, and that's going to give us 12 petals. Oh, shoot, that's not going to work. Okay, so maybe I'll plug in a 3. How about I plug in a 3 for n? Could I do that? Well, I could, but that's only going to give us 3 petals. Oh, so it turns out that you can't make a 6-petaled rose. You can't make a 6-petaled rose because why? That's right, there's no even number that doubles to be 6. Think about that. There's no even number that doubles to be 6. Oh, so there's some roses that can't be made. Well, how about this rose? What if we want to have 4 petals that are 2 units long? 4 petals that are 2 units long. Can you write this one? It's going to be of the form R equals. That's right, we're going to use a 2 because we want it to be 2 units long. And since we want 4 petals, that's right, we're going to use a 2 for n. So we have 2 sine of 2 theta. Just kind of curious, what does that look like, 2 sine of 2 theta? We could type that one in. And we end up getting a little tiny rose. Okay, it's got 4 petals in each of those units. Each of those petals are 2 units long. Now, of course, you'd have to measure that diagonally. We don't really have a way to officially do that. But it does match with the specification. One more. How about trying to write an equation for this graph? This graph kind of looks like a polar spiral. It actually looks like a spiral of Archimedes. We want to make sure that we call it a spiral of Archimedes since there are actually other kind of spirals. What's the equation for a spiral? Yeah, it's just n theta. Okay, now be careful because n theta is not a circle since it has that theta in there, since it has that second variable. Now, if we want to have the point 50, 150, if we want to have that point 50, 150, what this is doing is giving us a little exercise in some simple algebra where we can plug in 50 for, we can plug in 150 for the radius, and we can plug in 50 for theta. And so this would mean, of course, that n has to equal 3. So r equals 3 theta. Basically saying that each angle is going to be tripled to give us the radius. All right, now it's going to be your turn to complete the assignment that goes with both of these polar classification days, and that should wrap things up.
All right, if you're at home and wondering what that 7th classification is, well, it's one that we already studied. It's a line. That's right, we're talking about the situation where theta equals A. You know, when A is the angle. So go ahead and add this to your chart. That way you can distinguish when theta is equal to a number, we just get an angle. Like, I don't know, like maybe theta equals 30 degrees. Yeah, you're just going to get a line that's tilted at 30 degrees. Now, especially I want to make sure that you don't confuse this with the circle, and particularly the circle where r equals a, because that's a whole different scenario. That means that a is the radius. But again, up here we know that theta equals A is the angle. And so two different equations, two different graphs. And especially don't confuse either of these two graphs with the spiral of Archimedes. Because when you have the spiral of Archimedes, remember, you actually have two variables. You have r equals theta, or probably as we saw it today, r equals a theta. Of course, that means that theta, as theta increases, so does your radius, and that's why we end up with a spiral shape. So be careful, three different equations, three different graphs, three different classifications, but that should round out your chart.